In this video, we're actually going to be solving systems that contain three variables. And you're going to notice that when we have three variables, like in this first problem, we have an x, y, and a z, we'll need three equations. So three variables, three equations. So these can get kind of nasty. Now, the directions here are going to sound so confusing as we go through them, but let's talk about them anyway, and then we'll actually do it. Step number one, choose two equations in which you can easily eliminate a variable. So we're going to group two of the equations together. We're going to eliminate some variable, and we're going to call our resulting equation, just for the simplicity of talking about it, we'll call it equation A. Then we're going to group two other ones together and eliminate the same variable, and we'll call our new equation there equation B. Once we have those two equations solved with one variable eliminated from each, we will then put our resulting two equations, our equation A and equation B, together, and then it'll be just like what we've done in the past. So let's give it a shot here. Now, substitution or elimination can be used together here. It doesn't matter which ones you use. So what I'm going to do, I noticed that since I have just a plain old plus y here, what I'll do is I'm going to group the first two together, and we'll use those to find equation A. Then we'll group the last two together, and we'll use those to find equation B. Now, our plan is, since I have y by itself, I can very easily eliminate y. So that's something else you need to know, is what variable are you going to try to eliminate here? So we're going to group 2x minus 6y plus 9z equals -8 together with 5x plus y plus 2z equals 10. And we're going to use this to try to find some equation. And then to find equation B, I'm going to group 5x plus y plus 2z equals 10, along with 3x plus y minus az equals -28. And we're going to use the exact same principles of substitution and elimination. Now here, since I have everything lined up, I'm going to go ahead and try to use elimination. So what you got to do in both groups is you got to try to eliminate the same variable. The variable that I chose was my y's. So to get my y's eliminated, in my first group, my first equation, I'll leave the same. But in my next equation, I need, in order to get my -6y to cancel, I'm going to give me a positive 6y. So I'm going to multiply the entire equation here by a positive 6. And here's the equation I come up with. Now when I add the two together, notice that my y's will be gone. And again, we'll call this our new equation A. Now we're going to do the same thing. We're going to somehow try to get rid of our y's on the other one. So I'm going to leave my first equation the same. And my second equation, I'm going to multiply by -1 to get the y's to cancel. And now when I add my two equations together, again, notice that I have no more y's. And I will call this new equation that we have equation B. Now what we're going to do after that is we're going to pair our equation A and our equation B together. And we're going to do the exact same thing that we've been doing. And now that I have my equation A and equation B together, you can use substitution, you can use elimination, you can use either, but now I'm down to two equations, and my two equations have two variables, which is identical to the substitution elimination that you've been working. So I believe that I'm going to try to get rid of my x's. So my first equation, I'll leave the same. And my second equation, I'll multiply by -16, and that's going to give me the -32 right here that I'm going to need to cancel with my 32x's. Now, as I add these two new equations together, look what happens. The x's are completely gone, and I'm left with this. And solving this little one-step equation, divide by -139, you find out that z is equal to 4. Now, what we've got is one of our three answers. We are looking for an x, we're looking for a y, we're looking for a z. Now, here's what you've got to do. Once you find a z, go back to one of the two, either equation A or equation B. Let's plug the z in there because I have just an x and a z in those equations. So therefore, if I plug it back in there, I can now figure out what my x value is. So let's do that. I'm going to plug it into this second equation here, and I'm gonna end up with this. And once I move my 40 over and I divide by 2, I'll find out that x is now -1. So now I have an x value and I have a z value. And in order to find a y value, now is when I go back to my originals. I have an x, I have a z. Now let's take and plug it into one of these. Let's see, the cleanest one is probably this one. Let me circle that again. So with an x value of -1, let me change colors here. We'll do a green. An x value of -1 does 5 times -1 is -5 plus y. Z is 4, so plus 2 times 4 is 8 is equal to 10. Clean that up, it gives you y plus 3 is 10, so y must be 7. Now, you're going to write your answers in an ordered triple form. Normally you have ordered pairs, but since we have 3 different values, x is -1, y is 7, z is 4. That is the point where those 3 planes cross. This is a 3-dimensional plane. If you were to graph it, these 3 planes will cross at the point -1, 7. Okay, number 2, we're looking to do the exact same thing. To find equation A and equation B, we can again pair either of these equations together. Now, let me explain what I look for. I look for x, y, or z values that's by themselves. So I'm going to pair these two together because I know that I can use this y to very easily cancel out another y. And since I can use that y, I'm also going to pair these two together to find equation B. Now, it just so happens that in both of these, again, that y, since y is by itself here, is going to be the easiest equation to eliminate. So let me zoom in here and let's work on this. In order to eliminate my y's here, I have a -4y in the second equation. If I can get a +4y up here, then we can cross them out. So I'm going to take my first equation. I'm going to multiply everything by 4. And my second equation should be able to stay the same because I already have the -4 here. Now my y's are ready to cancel out. Combining the two equations gives me 22x's, -9z's is equal to 221. So no more y's. So over here with equation B, we need to do the same thing. We need to somehow get rid of the same variable. So I have a -7y in my second equation. So I need a +7y in my first equation. So let's take the first equation, multiply everything by 7. And the second equation will be able to stay the same because I already have my -7y's. Now when I add my two equations together, you see that I get 30x. The y's are gone, -32z's, and 85 and 315 gives me 400. So my equation A and equation B is now finished, and both of them have only x's and z's. Now let's pair those two together and try to figure out what x and z are. There you see my new equation A and equation B together. Now to get rid of either x's or z's, we can use substitution or elimination. This is already set up for elimination. So what I'm going to do is, I guess we could take our first equation, and to get these, we'll eliminate our x's. To get our x's the same, I can multiply my first equation by 30. And I can multiply my second equation by -22, and that's going to make these two values the exact same number. And there you see the results. Now it's very handy to have a calculator for this because there's a lot of large number calculations to be done here. Notice your x's are gone. When you combine your z's and you combine your constants to the right side, here's what you get. And then finally dividing by 434 would give you that z has a value of -5. Now that you know your z value, let's go back and let's try to find the other values. Go back to the original. Notice the originals have x, y's, and z's. However, we want to take it a step at a time. Go back to just these, your equation A and your equation B. Let's plug that -5 into one of those because those don't have x, y's, and z's. They only have 2 variables. So when I plug that z value in for one of these z's, that's going to tell me what my x is. So I'll take, and either one of them are fine, I'll take this one. We're going to plug in -5 for z, and we'll now have 22x. A -9 times a -5 would be a +45 equals 221. Subtracting 45 and dividing by 22 gives you an x value of 8. And now that we know that x is 8 and z is -5, now we can go back to one of the originals. And it doesn't matter which one, but now that you have 2 of them, the first one is probably the cleanest out of all of them. Let me change colors here. So we now have 4 times x. Since x is 8, that'd be 32, plus y. A negative 3 times a negative 5 would be a positive 15 is equal to 45. 32 and 15, that is 47 plus y is 45. So you find out that y would have to be negative 2. So therefore your point would be your ordered triple, 8 is x, negative 2 is y, negative 5 is z. Now these can also be solved with substitution. The exact same way. So what I'm going to do is I'm going to solve. Notice that z is nearly by itself. I'm going to move my z over and solve it for z. So I have 9x minus 4y plus 60 is equal to z. So I interchange these two values. And here's what I got. So now what I'm going to do to find my equation A and equation B is I'll pair these together to find A, and I'll pair these two together to find B. So the way I'm going to do that, though, is I'm going to use this equation, and I'm going to substitute in to find equation A and equation B. So here you see I've got the two paired together, equation A and equation B. Let's zoom in so we can see it a little bit better as we work. So the first two equations, I have z is equal to this, so I'm going to take my first equation, 5x minus 3y plus 8 z, and in the place of z, I'm plugging in 9x minus 4y plus 60. And that was equal to negative 59. So take out the z and plug in whatever you got when you solve for z. Then it's just simple cleanup. 5x minus 3y. Distribute your 8 would be a positive 72x, a negative 32y, and a positive 480 equals negative 59. And then we're just combining like terms. 5 and 72 gives you a total of 77 x's. Negative 3 and negative 32 gives you negative 35 y's. Move the 480 across, and that's going to equal negative 539. Your other equation, doing the exact same thing. You have z is equal to this, so we're going to substitute it in. 5x plus 2y plus 4z. And we know that z is equal to 9x minus 4y plus 60, and that's equal to negative 47. So again, we simply took out the z and plugged in what it was equal to. Clean up, you have 5x plus 2y plus 36x minus 16y plus 240 is equal to negative 47. Combine your like terms, 5 and 36 gives you 41 x's. 2 and negative 16 gives you negative 14 y's. Move the 240 over to get it in standard form, and that would be negative 287. So now you have your equation A and you have your equation B. And what we always do next is let's group A and B together. Now, a lot of times when we group these two equations together, we'll just take and multiply the first one by this number and multiply the second one by the negative of that number, just to make it easy. Now, sometimes, though, you might recognize something like this, that, hey, I know that 35 and 14 are both factors of 70. So I know that I can turn both of those values into a 70. So the way I'm going to do that, we'll take our first equation and we'll multiply it by a negative 2. And that'll give me a 70. I'll take my second equation and I'll multiply it by 5, and that would give me a negative 70. And that's going to change both my equations into something that will cancel my y's out. And as I do this, here's what I'm left with. Notice that when I add these two equations together, my y's will cancel, and it leaves me with 51x is equal to negative 357. And when I divide by 51, it gives me x is negative 7. Now, as we go back and we can plug that into either one of these, equation A or equation B, anywhere where we have just the two variables to plug in, I'll choose, let's see, we'll just plug it into this equation B over here. And that gives me, as I plug it in, let me just come right there below it as I plug it in. 41 times negative 7 gives me negative 287. minus 14y equals negative 287. So that's kind of nice because as you move that over by adding 287, you get negative 14y was 0. So y would have to be, when you divide, 0. And since now you have both x and y, you can go back to your original equations. Or, since we're using substitution, I always tell you that substitution, wherever you solve for z or one of the variables, that's always the best place to plug back in. Because now 9 times x is negative 63. Negative 4 times 0 is 0. Plus 60 is equal to z. So therefore, when you add those together, you get negative 3 is equal to z. So there's your three answers. Your x is negative 7, your y is 0, and your z is negative 3. Okay, number 4, we'll use substitution again, and I noticed that x would be very easy to get by itself, so what I'm going to do, I'm going to pair my first two together to find equation A. We'll pair the first one and the third one together to find equation B. So to find equation A, the first two. Now, as I wrote these down, I want to point out that I went ahead and solved for x. I moved this term and this term to the right side because in order to use substitution, I need either x equals, y equals, or z equals. I'm going to do the same thing on B. I'm pairing my first equation and my last equation. I'm going to go ahead and solve for x on it as well. Okay, and there's what you get. And again, the next step, we're going to use our substitution. And since I've solved for x, now you do have to solve for the same variable in both. The same variable has to be eliminated in this step for equation A and equation B. If you eliminate two different variables, then it's going to be really confusing for this next step. So let's eliminate our x's by using substitution. And again, all I did there was I took this x out and I plugged in what x was equal to, distributive property and combining like terms. And this is what you end up with. Now let's do the exact same thing. That's my equation A. Let's do the exact same thing on equation B. So substitution, since x is equal to this, we're going to plug it in for our x. And now again, we're going to clean that up we're going to distributive property and combine all of our like terms. And there's my new equation B. So now that I have my equation A and my equation B, we can group those two together. And let me do that in a different color. Let me draw me a line right here. We're going to do it in a different color. And then we'll try to eliminate either our y's or z's then. So now to get rid of y's or z's, and it doesn't matter, you can use substitution or elimination. Since it would be hard to get y or z by itself without having any fractions. Again, elimination is always your best method when it's like this and you can't easily solve for y or z. So what we can do is we can take our numbers right here. If we were to multiply this first equation by 4 and the second equation by the other number, negative 23, not just 23, that'll give us our opposites. Then we're going to end up with two numbers here and here that will cancel each other out. So let's go ahead and do that. And there's what I now have. And you can see that I have the 92y and the negative 92y that will cancel each other out. Combining these two equations after my y's are canceled, here's what you now have. And then in your last step, when you divide by 213, you'll get that z has a value of 9. Now that you find z, you can go back and plug it in here. You can go back and plug it in here into equation A or equation B. It does not matter. We'll choose, let's see, we'll do the 23y one. And I'll just plug it in right here. It's the same equation. Since z is 9, we now have 23y minus 10 times 9 is 90 equals negative 136. Move the 90 over and divide by 23, and you'll find out that y has a value of negative 2. And now that we have y and z, now you go back to your original equations. It doesn't matter which one you choose. However, I've told you before that it's always easiest to use the one that you solve for the other variable. So you have x is equal to 5 times y minus 3 times z plus 39. That'll be negative 37 plus 39, so x would have a value of 2. So your point where these cross would be 2, y is negative 2, z is 9. Okay, we got one more of these before we go to the application problems. And again, we'll go back and actually use elimination on this just to remind you how to do that. I like to pair up the equations that have single x's, single y's. I like to pair those with the other ones because it's going to be easier to eliminate. So I'm going to pair these two together for equation A. Then I'm going to pair the first and the last one together for equation B's. Now the next decision you're going to have to make is, okay, what variable am I eliminating? Do I want to get rid of the x, y's, or z's? Now the x's or y's, since you have a single x here and a single y, would be pretty easy to get rid of. However, the z's I'd probably stay away from because you're going to have to change both of your equations. So it does not matter, just pick one, but make sure that whatever variable that you choose, that you eliminate the same variable in both. We'll go ahead and eliminate the x's in both. So since I have a negative 3x down here, in order to get a positive 3x here, I'll multiply the entire first equation by 3. And then after doing that, I'm going to leave my second equation the exact same. Now the x's are ready to eliminate. Let's add the two together. 3 and 7 gives me 10 y's. 9 minus 2 gives me 7 z's. And 36 minus 35 is 1. So there's my equation A with no x's left. Now let's move on to equation B. And since I eliminated my x's there, I'm going to have to eliminate the same variable here. So since I have 7x, I'm going to take my first equation, multiply it by negative 7. And my second equation will again stay the same. Now when I add those two together, you can see that again my x's will cancel and leaves me with negative 13y, a negative 26z, and negative 84 and 32 is a negative 52. Now, I do notice something about this, and this is always legal. You don't have to do this, but 13, 26, and 52 are all divisible by 13. So if you would like to reduce equations, it makes your job in the end a whole lot easier because now you have a nice, clean y plus 2 equals, or y plus 2z is equal to 4, which looks a whole lot better than the equation did before. So if you can ever reduce an equation, that's always nice. So there's your equation B. So now that I have equation A and equation B, let's pair those two together. And I'm actually going to do something different on this because up to this point, I've used elimination. With this system that I have left, I have two variables. I have two equations. It doesn't matter which one you use. You can use substitution or elimination. Just to change it up again, since I started with substitution, since I started with elimination, I can now, if I'd like to, use substitution. So I could take my second equation, I can move my 2z over and do y is equal to 4 minus 2z. And since y is equal to that, in the place of my y in the other equation, I can replace it with that. I can do 10 times 4 minus 2z plus 7z is equal to 1. So I solved this equation for y, plugged it into the other, and look what I have left. I've eliminated my y's completely by using substitution. Now, once I have this, I'm going to solve that equation. And I do so by distributive property, combining like terms. I move my 40 over. In my last step, I divide by negative 13, and I find out that z is 3. It's always best to go back to where you'd use substitution. Since z is equal to 3, then y would equal 4 minus 2 times 3 is 6. 4 minus 6, that would be negative 2. So now that I have my I have my y and my z, I can now go back to an original. The cleanest original is x plus y plus 3z is 12. And let's plug those in. It gives me x. My y is negative 2, so let's plug that in for my y. My z is 3, so that'd be plus 9 is equal to 12. That would be x plus 7 is equal to 12, so that means that x would have to be 5. So my x value is 5. My y value is negative 2. My z value is 3.